This video is going to be for algebraic representations, also some dilations for 8th grade. Looking at this very first section here, option number 1 right here, when we're looking at it, we've already talked a lot about algebraic representations. Right here is where we start, and these are our instructions over here on the right side showing us what we are going to do. Well, from x to x, nothing changes. From y to y, nothing changes. So, for example, if I was going to follow that set of instructions, if my starting point was 2010, well, what would happen is absolutely nothing. We leave the x and the y both alone, which is why we end up with 2010 when we're finished. And so this whole line pretty much ends up looking the exact same. It's just showing that whatever x and y are, we keep them the exact same. Now down here for option 2, it says whatever our x and our y are, we are going to take it, and whatever x is, we are going to add 3 to it, and whatever y is, we are going to subtract 1 from it. This is kind of like the translations that we've been doing. So onto the same example, if I started out with 20 and 10, what I have to do is that 20 is my x, so I have to add 3 to the 20. The 10 is my y, so I have to subtract 2 from it. So that just shows me what's being done to it. And you can see over here on the side that if I started out with 20 and 10, that I should end up with 23 and 8 when I'm finished. Again, we just did 20 plus 3 to get 23, then we did 10 minus 2 to get the 8. On line 3, believe it or not, we've actually been doing these, but we haven't talked too much about them yet. This is showing a dilation. So it's saying whatever x and y are, we are going to take those, and our x, we multiply it times 2, and our y, we also multiply it times 2. So again, I'm going to use the exact same starting point. I'm going to take that 20, and I'm going to take that 10. And here's what I'm going to do. I'm going to multiply both of them. We're multiplying by that same 2 that is over there on the left side. So when I do 20, I'll do 2 times 20, and then I'll do 2 times 10. So my starting point was still that 20 and 10. We multiplied them both times 2, and we ended up with 40, and we ended up with 20. On the final line here, this is similar to the reflections that we did. It's saying that we are going to take our x and our y, and whatever we are, or whatever they are, the x ends up staying the exact same. Nothing changed from x to x. The y, well, whatever the y is, I'm going to take it and I'm going to swap the sign on it. If it's positive, it becomes negative. If it's negative, it'll become positive. That's what that sign there tells me to do. So again, same example. That 20 and that 10, these are the numbers that I'm going to start with. Well, 20, because it's my x, is going to stay the exact same. Nothing will change about it. The 10, I'm just swapping the sign on it, and that's what that is indicating. So it's going to look pretty much the same over here on this side. I started with 20 and 10. I ended up with 20 and negative 10. And so on this part right here where it says line 1 is A, line 2 is A, line 3 is A. Well, line 1's not really anything, so we're going to put NA for not applicable. Nothing actually happened on that one. For line 2, that is a translation because we're shifting the image. So this is a translation. Line 3, because we multiplied both sides times 2, that's a dilation. And line 4, just because we swapped the sign on one of them, it's going to be a reflection. So again, these are the things that we've talked about so far. Unfortunately, we've still got more stuff coming. So number 1 says, on line 1, what happened to x and y? Well, nothing changed on them. So the answer is nothing. Number 2 says, on line 2, what is happening to x and y? Well, what we did is we shifted it. So because we added 3 and then subtracted 2, we're adding 3 to the x, and then we are subtracting 2 from the y. So C. Number 3, on that one, it just shows that we're going to multiply both the x and the y by 2. Now the answer choices were a little bit funny on this one. We know nothing didn't happen. It's not going to be a reflection. Now C and D are a little weird on this one. It says x becomes 20 and y becomes 40. Well, when I look at that line, let's see, this is for line 3, x became 40 and y became 20, so C is out. Then D says if you plug in 20 for x, which we did, you will get 40 back out, which is what what we ended up getting. So the answer is D on number 3. On number 4, it says on line 4, what is happening to x and y? Well, the only thing that happened is we had that that y, then ended up changing sign. So now I've got to go through my answers and see which one indicates that. So it's not A. X becomes a negative, but y becomes a positive. That's not what happened. We said only the y changed. So x stays x, and y became negative. And I don't even like that I have negative there. It really should just say that y changed signs. So it is C on number 4. On this next section, what you're doing is they're going to give you they're giving you an algebraic representation that you are going to apply. So on 5, 6, 7, and 8, you are going to use that same algebraic representation. On number 9, 10, 11, and 12, you are going to use this algebraic representation. On 13, 14, 15, 16, you are going to use this algebraic representation. So I'm going to show you one from each, and then you'll be on your own after that. So on number 5, here's my point that I've got to change, and I'm going to use this part of the algebraic representation. It shows that I'm going to multiply my x times 9, and I'm going to multiply my y times 9. So right here, I'm going to be doing 2 times 9, and I'm going to be doing 6 times 9. So I should end up getting an 18, and then, because I did 2 times 9, and then 6 times 9 is going to be 54. Unfortunately, there does not seem to be a correct answer on that, so we're going to have to fix our own. Oh, yep, it's right there. My mistake. It's B. All right, so you try the other ones on your own. For number 9, again, we're going to be using this part of the algebraic representation. So it says whatever my x is, I have to add 3 to it. So I'm adding 3. Whatever my y is, I'm going to subtract 6. So when I work those out, 2 plus 3 is 5. 6 minus 6 is 0. The only one that matches is D. On this section here, it says whatever my x is, I'm going to leave it alone. So nothing happens to this number. Whatever my y is, I'm going to change sign on it. Well, that 6 is positive, so I'm going to change it to a negative. So I'm looking for 2, negative 6. And you guys will finish up that section on your own. Here on the back side, I'm just going to give you some reminders, but for the most part, you're going to be doing these on your own. Take a look. Number 17 says, which dilation results in a figure that is smaller than the original? Well, the dilation, for it to be a dilation that makes it smaller, my number has to be whatever my scale factor is, it's got to be less than 1. So looking at these, take a look at that, see if it's less than 1, see if that's less than 1, less than 1, less than 1. Whichever one is less than 1, that's going to give me a smaller image when I'm finished. Number 18 is almost the exact same thing, except it wants to know which one is going to give you a larger image. So for my image to be larger, my scale factor has got to be greater than 1. I'm going to label this part just so you guys don't get confused by the notation. I'm saying my scale factor is bigger than 1, and on number 17, I was saying my scale factor is less than 1. So again, take a look at your numbers, see which one is bigger than 1 on number 18. Number 19 says, by what scale factor does the length of segment AB in the figure shown change under the dilation? And then it gives you the dilation right here. There's not too much to do on this one. Don't let the graph fool you. Just look for your scale factor. I would definitely use that algebraic representation and figure out which one gives you the dilation. On number 20, it says, which proportion could be used to find x? There are a bunch of different ways to go at this. I recommend highlighting if you're not familiar with it, but just keep in mind whatever proportion I've got, that I have to have this side somehow related to here, and it has to be related to here. And that relationship works all the way around. But if you didn't follow that, what I would do is I would definitely recommend sticking with, so like this side x is going to be related to that side 5. This side 4 is going to be related to that side 8. And I would go through on my A, B, C, and D, and I would just highlight the numbers that match. So all my 5s are going to be red the way I've got it set up. All of my X's are going to be red. All of my 4s are going to be blue. And all of my 8s are also going to be blue. So you figure out which one of those is going to give you a side-to-side relationship and an up-and-down relationship. Keep in mind that this right here, well, we can call this, I don't know, figure 1 and figure 2. because that's also a relationship. 4 and 5 are related because they're both on figure 1. X and 8 are both related because they're both on figure 2. Number 21. It says triangle JKL was dilated by a scale factor of 1/3 to form triangle PQR. Which statement is the algebraic representation of the dilation? Pretty much you are just applying the dilation or the scale factor. Remember, scale factors are multiplication. All right, for number 22. It says which algebraic representation could be used to show the dilation of triangle XYZ by a scale factor of 3? It's going to be almost identical to number 21. You are just identifying between A, B, C, and D which one uses the scale factor of 3. And whatever your scale factor is, it has to be multiplied. The same number has to be multiplied times X and times Y. And finally, number 23 says which algebraic representation could be used to show the dilation of trapezoid ABCD by a scale factor of 1/3. So again, my scale factor is 1/3. I need to multiply that by both X and Y. What this one's going to try to trick you on is if I'm dilating, for example, if I'm dilating A, well, my new one is going to be A prime. If I'm dilating D, I would be going to D prime. C would go to C prime. B would go to B prime. I can't go from point A to D prime. I'd have to go from point A to A prime. So make sure that you're watching that notation whenever you're answering between A, B, C, and D on that one. If you have any questions, make sure you guys come ask me and I'll help you out.